Welcome to our latest video, which has the title Understanding Moles. This video is suitable for GCSE students. By the end of this video lesson, you should understand the concept of moles as counting units for particles such as atoms, molecules and ions. You should also understand the number of particles in a mole is given by the constant Avogadro's number, and also be able to convert both grams of a substance into moles and moles of a substance into grams. Now, in our previous video, we learnt about the term relative atomic mass, and we learnt that atoms and molecules are really small in terms of their mass, and it's impossible to measure the mass of individual atoms or molecules. So therefore, we compare the mass of lots and lots of atoms and molecules, and we have a relative scale. Now, the relative atomic mass is the mass of an atom on a scale where carbon has a mass of 12 and hydrogen has a mass of 1. So you can see in this diagram that a carbon atom has the same mass as 12 hydrogen atoms. And that's why the AR of carbon is 12 and the AR of hydrogen is 1. Because a carbon atom has a mass that's 12 times bigger than the mass of a hydrogen atom. Now, as we said in our previous video, you don't have to learn the AR values for the different atoms. These are given to you in exams, and very often they'll be included in the periodic table that you're given, because most periodic tables now list the atomic number alongside the symbol together with the AR value for that element. Now, in our previous video, we also learnt about the relative molecular mass, which is sometimes called the formula mass. Now, this is the mass of one molecule of an element or compound on a scale where a hydrogen atom has a mass of 1 and a carbon atom has a mass of 12. And this can be found by adding up the AR values of each atom in the molecule. So if I'm asked to find the MR value of water, the relative molecular mass of water, I simply have to add up the AR values of all the atoms present in water. So this would be 1 plus 1 plus 16 equal to 18 for the MR of water, because there's two hydrogens that each have an AR value of 1, and there's an oxygen which has an AR value of 16. Now, if I'm asked to work out the MR value of O2, oxygen molecules, it would be 16 plus 16, which would be equal to 32, because an oxygen molecule is made up of two oxygen atoms, each with an AR value of 16. And if I'm asked to work out the MR value of CH4, this would be 12 plus 4, which would be equal to 16, because carbon has an AR value of 12 and hydrogen has an AR value of 1, and there's 4 hydrogens in CH4. Now, in this video, we're going to focus on the concept of a mole. Now, we've seen previously that it's impossible for a scientist to weigh out one atom or one molecule of a substance because they have such a small mass. Now, in chemical reactions, we're dealing with huge numbers of particles reacting at any one time, so we use the term mole as simply a counting unit for particles. Now, there are 6.022 times 10 to the 23 atoms, molecules or ions in a mole. Now, that's a huge number. It's basically a 6 followed by 23 zeros. Now, this number is called Avogadro's number, or Avogadro's constant, after the Italian scientist Amedeo Avogadro, who discovered this number. Now, at GCSE, you'll never be asked to remember Avogadro's number, so you don't have to know that it's 6.022 times 10 to the 23. But you do have to understand the concept of a mole, the idea that a mole is a set number of atoms, molecules or ions. Is simply a counting unit that makes it easier when we're discussing the number of atoms, molecules or ions, because we're dealing with such big numbers in chemical reactions. Now, many objects in our everyday lives come in similar counting units. For example, you buy shoes by the pair or you buy eggs by the dozen. Now, atoms, molecules and ions are used by the mole, and the number of moles present of a substance can be found using the following formula. The number of moles is equal to the mass in grams divided by something called the molar mass, which is simply the number of grams we need to have a mole, which is either the AR value if you're dealing with atoms or the MR value if you're dealing with molecules. So a mole is always 6.022 times 10 to the 23. But what changes is the molar mass, because the molar mass is how many grams you need to have a mole. And it's equal to the MR value when you're dealing with molecules or the AR value when you're dealing with atoms. Now the MR value of water is 18. So if you have 18 grams of water, 18 grams divided by the molar mass, the MR value of 18, would give you a mole. So I need 18 grams of water to have 1 mole of water. And if I have 1 mole of water, I have 6.022 times 10 to the 23 molecules of water. Now, if I want a mole of iron atoms, the AR value of iron is 55.9. So if I have 55.9 grams of iron, I would have 6.022 times 10 to the 23 atoms of iron. And if I had 32 grams of oxygen, the MR value of oxygen is 32. So I'd have a mole of oxygen, and I'd have 6.022 times 10 to the 23 molecules of oxygen. And that's how it works. I require different numbers of grams of each substance to have a mole. And that's because the MR and AR values of different substances are different. So we're now going to look at an example question where we're asked to calculate the number of moles present in the following substances. So we're converting grams to moles, and we're given the AR values to help us. Now if you'd like to have a go at this question first before I go through it, just read for the question, pause the video and have a go at it. But if not, just fast forward and I'll go through the answers. Now in this example question, we're asked to calculate the number of moles present in the following substances. We're asked to convert 12 grams of carbon to moles. We're asked to convert 80 grams of magnesium oxide into moles. And we're asked to convert 10 grams of sodium hydroxide into moles. Now the formula we need to use is moles equals mass over molar mass. And molar mass is in grams per mole. And it's equal to either the AR value if you're dealing with atoms or the MR value if you're dealing with molecules. Now in question 1a, where we're asked to convert 12 grams of carbon into moles, we're dealing with carbon atoms. So the molar mass is going to be simply the AR value for carbon. So moles equals mass over molar mass. The molar mass is equal to the AR value of carbon, which is 12. So the moles is equal to 12 grams over the molar mass, which is the AR value here, because we're dealing with atoms. So it's 12 grams divided by 12, and that will give us moles equal to 1. So we have 1 mole present here if we have 12 grams of carbon. And you have to remember that the molar mass is simply how many grams I need for a mole, and it's equal to the AR value if we're dealing with atoms and the MR value if we're dealing with molecules. Now in question B, we have 80 grams of magnesium oxide, so the moles is equal to the mass over the molar mass, and because we're dealing with a molecule here, the molar mass is equal to the MR value for magnesium oxide. So the MR value of magnesium oxide is equal to the sum of the AR values of the atoms present. So magnesium has an AR value here equal to 24, and oxygen has an AR value equal to 16. So the MR value of magnesium oxide is equal to 24 plus 16, so it's equal to 40. So moles equals mass over molar mass, and the molar mass is equal to the MR value here because we're dealing with molecules. So it's 80 grams over the molar mass, which is 40 grams per mole. So we have 2 moles of magnesium oxide here present if we have 80 grams of magnesium oxide. Now for C, we have 10 grams of sodium hydroxide. So once again, we use moles equals mass over molar mass, and for the molar mass we use the MR value here. So the MR value of sodium hydroxide is worked out by adding up the AR values of each atom present. So the MR value of NaOH is equal to the AR value of sodium, which is 23. And then we find the AR value of oxygen, which is 16. And we add it to the AR value of hydrogen, which is 1. And that will also give me an MR value equal to 40. So to work out the number of moles that I have present, if I have 10 grams of sodium hydroxide, I do moles equals mass over molar mass, which is the MR value here. So it's 10 grams divided by 40 grams per mole, and that will give me a number of moles equal to 0.25. Now, to improve your understanding of moles, it's important to reflect on what these values mean. Now remember, 1 mole is equal to 6.022 times 10 to the 23. So basically a 6 with 23 zeros, a huge number. So if you have 1 mole of carbon, you're going to have 6.022 times 10 to the 23 atoms of carbon. So 12 grams of carbon is going to give me 6.022 times 10 to the 23 atoms of carbon. Now, in addition to being able to convert grams to moles, at GCSE you would also be expected to convert moles of a substance to mass in grams. Now, to do this, we simply rearrange the formula. So the mass in grams is equal to moles times the molar mass, which is either the AR if we're dealing with atoms, or the MR value if we're dealing with molecules. And you can see I've represented this equation here with a formula triangle that you could use to help you rearrange this formula. So for example, I might be asked to convert 2 moles of water to its mass in grams. So to do this, I've rearranged my formula. So mass in grams is equal to moles times the molar mass. Now the molar mass here is the MR value because water is a molecule. So the MR value of water is 18. So if I want to find out the mass that 2 moles of water would be, I just simply do moles times molar mass. So it's 2 times 18, and that would give me a mass of 36 grams. So now we understand the concept of the mole, we're going to explain how this links to chemical equations. Now I'm going to use the following equation to explain this. So here we have methane reacting with oxygen to form carbon dioxide and water. And when we look at the chemical equation, it's CH4 plus 2O2 goes to CO2 and 2H2O. So I could represent this equation by just drawing out the molecules here. So I've drawn a methane molecule, I've drawn 2 oxygen molecules, I've drawn 1 carbon dioxide molecule, and I've drawn 2 water molecules. And I've used the equation here to find the ratio of molecules. 1 methane to 2 oxygen molecules to 1 carbon dioxide molecule to 2 water molecules. Now, in reality, we wouldn't just have 1 molecule reacting with 2 molecules, say. We'd have billions and billions of molecules reacting. So it's important for us to use moles here rather than just talking about individual molecules and atoms. So if we look at our equation here, it really represents molar ratios. So 1 mole of CH4 would react with 2 moles of oxygen to form 1 mole of carbon dioxide and 2 moles of water. Because remember, a mole is just a counting unit. It's just a set number of molecules or atoms or ions. And a mole is equal to 6.022 times 10 to the 23. It's Avogadro's number. So if we had 1 mole of CH4 reacting with 2 moles of O2, we would have 1 mole of carbon dioxide and 2 moles of water, because that's what the equation tells us that the ratio is. Now, we might not have 1 mole, we might have 5 moles of methane. So 5 moles of methane would react with 10 moles of oxygen to form 5 moles of CO2 and 10 moles of water, because the ratio is 1 to 2 to 1 to 2. And if I had 0.1 mole of CH4, it would react with 0.2 moles of oxygen, because the methane and the oxygen are in a 1 to 2 ratio. And this would produce 0.1 mole of carbon dioxide and 0.2 moles of water. So the equation and the numbers in front of the molecules tell us the ratio of moles. So here we have 1 CH4 reacting with 2 oxygens, forming 1 CO2 and 2 waters. So our ratio of moles is 1 to 2 to 1 to 2. And that's what a chemical equation tells us. It tells us the molar ratios of reactants and products. So now let's test your understanding of what we've covered in this video with some practice questions. Here's the first practice question. Read through the question, pause the video, have a go at it, and then we'll go for the answers. So this first practice question is asking you to calculate the number of moles present in the following substances. Now remember, moles is equal to the mass over the molar mass, and the molar mass is either equal to the AR value or the MR value. If you're dealing with atoms, we use the AR value, and if you're dealing with molecules, we use the MR value. So in this question, they've given you the AR values of the atoms that you need to calculate MR values. Now, for the first question, we have 34 grams of ammonia. Now, ammonia is a molecule, so I need to use the MR value in my calculation. So the MR value of ammonia, NH3, is equal to 14 plus 3 lots of the value for hydrogen. So 14 plus 3. So the MR value is 17. So to work out the moles, I do mass over MR. So it's 34 grams over 17 grams per mole, which is the molar mass. And remember, that's equal to the MR. So it's equal to 2 moles. Now for question B, I'm asked to convert 80 grams of methane into moles. Now remember, moles is equal to mass over the molar mass. And because methane is a molecule, I need to use the MR value here. So the MR of methane is going to be 12 plus 4, because carbon has an AR value of 12 and hydrogen 1, and there's 4 hydrogens. So the MR value of methane is 16. So to work out the moles, I just do mass over the molar mass, and the molar mass is equal to the MR value. So it's 80 divided by 16 grams per mole, which is equal to 5 moles. And then for part C, we're asked to convert 4.4 grams of carbon dioxide into moles. So moles is equal to the mass over the molar mass. And because carbon dioxide is a molecule, we use the MR value here. So the MR value of carbon dioxide is equal to 12 plus 16 plus 16. So that's equal to 44. So to calculate moles, I just do the mass, 4.4, divided by the MR, 44, and that will give me the number of moles. So 4.4 divided by 44 is going to be equal to 0.1 moles. So here's our second and final practice question. Read for the question, pause the video, have a go at it, and then we'll go for the answers. Now in question 2, you're asked to calculate the mass of the following substances in grams, and they're asking you to convert moles to mass for aluminium, calcium oxide, and sodium chloride. And the formula to convert moles to mass is as follows. Mass is equal to moles times molar mass. And the molar mass is either the AR value if you're dealing with atoms, or it's the MR value if you're dealing with molecules. Now in this first question, we're asked to convert 2 moles of aluminium into the mass in grams. So aluminium is an atom, so we need to use the AR value here for the molar mass. So the mass is equal to moles times molar mass, and the molar mass that we're going to use is the AR value of aluminium. So the AR value of aluminium is 27. So to find the mass, we do moles times the molar mass, which is the AR value. So it's 2 times 27, and that will be a mass of 54 grams. Now for question B, we're asked to work out the mass of 0.5 moles of calcium oxide. Now calcium oxide is a molecule, so we have to use the MR value here for the molar mass. So mass is equal to moles times molar mass, and it's the MR that we use for the molar mass. So the MR of calcium oxide here is going to be 40 plus 16, because the AR value of calcium is 40 and the AR value of oxygen is 16. So that's going to be an MR value of 56. So to work out the mass is simply moles times molar mass, which is the MR value. So it's 0.5 times 56, which is equal to 28 grams. Now for question C, we have to convert 0.1 moles of sodium chloride into its mass in grams. So mass is equal to moles times molar mass, and for the molar mass we use the MR value here. So the MR value of sodium chloride is equal to 23, the AR value of sodium, plus 35.5, and that will give us an MR value equal to 58.5. So to find the mass in grams, mass is equal to moles times the molar mass, which is simply the MR value. So mass is equal to 0.1 moles times by the molar mass, which is the MR value, so it's 58.5. And that will give us a mass in grams of 5.85 grams. So that concludes this video lesson. So after watching this video, you should now understand the concept of moles as counting units for particles such as atoms, molecules and ions. And you should also understand that the number of particles in a mole is given by the constant Avogadro's number. And finally, you should be able to convert both grams of a substance into moles and moles of a substance into grams. So that concludes our video. Please check out our YouTube channel, Dr. O Chemistry, and our Twitter site, which contains lots of chemistry information and links, @RadaChemistry.